There we go.
Now we're good. Okay. So you might have read some headlines about global insect declines, and there are 3 billion fewer birds in North America than there were in 1970. And that's a pretty bad, bleak reality check about how ineffective our current landscape designs have been at sustaining the plants and animals that sustain us. And what we're going to be all about is creating landscapes that enhance local ecosystems rather than degrading them, and adding native plants to our landscaping so that these plants sustain our food webs, they help us sequester carbon, they maintain diverse native bee communities, and they help us manage our watersheds. So if we would do this in half the area that is now in lawn that we have to take care of, we can create what Dr. Tallamy here calls a homegrown national park. And he's going to talk about that. And it's a 20 million acre network of viable habitats that provide vital corridors connecting the few big national and state and city parks that remain, the natural areas. Now, this approach to conservation really empowers every one of us to play a significant role in the future of the natural world. And that makes us feel good that we're doing something for the greater good. And it's the brainchild of Dr. Doug Tallamy. He's the T.A. Baker Professor of Agriculture in the Department of Entomology and Wildlife Ecology at the University of Delaware. He's authored 106 research publications, and he's taught insect-related courses for 41 years. And one of his big research goals is to better understand the many ways that insects interact with plants and how such interactions determine the diversity of animal communities. So bringing nature home was the first book published in 2007, and that kind of kicked off this backyard revolution. And then Nature's Best Hope in 2020 became a New York Times bestseller, and you could tell that it had caught fire and people were beginning to really get into this concept. He's just recently published in 2021, The Nature of Oaks, which he's going to talk a lot about to us tonight. And of course, here in the Hill Country, we're very proud of our oaks, and we tend to maintain them and rather than cutting them down like a lot of other plants. Now, Dr. Tallamy has a lot of awards, a recognition from the Garden Writers Association, National Audubon, Garden Club of America, the American Horticultural Association, and you're going to find out why when we hear the presentation. So we're so honored to host Dr. Tallamy, and I'm going to turn the presentation over to him at this point. Dr. Tallamy?
Thank you, Patsy. That was quite an introduction. So let's get started. I do want to talk to you tonight about the nature of oaks. In other words, the number of species that are associated with oaks. But before I do that, I want to remind you what E.O. Wilson told us in 1987. And I know that was before most of you were born. But he said, insects are the little things that run the world. And he meant it. He told us why, which makes that global insect decline a serious problem. We've already lost more than 45% of the insects that run the world. And we're losing them because lights kill insects. We're losing them because neonicotinoids kill insects, and the light green areas are all the places we're using neonics. We're losing them because deforestation kills insects, because cars kill insects, because climate change kills insects. When we take areas like this and we change them into that, it kills insects. What does that have to do with oaks? Well, there's no better way to fix this. There's no better way to share our spaces with insects and the rest of nature than to plant an oak. And I'm going to talk to you about how well that works using oaks that I put in our property in the year 2000. We started in the year 2000 anyway. That's when Cindy and I moved into a 10-acre lot, part of a farm that was broken up. It had been mowed for hay before we moved in. And when you mow for hay in this part of the world, what you're really mowing is the rootstocks of all the invasive plants, autumn olive and multiflora rose and oriental bittersweet and Japanese honeysuckle and bush honeysuckle. And when you stop mowing, that's what comes back. So they stopped mowing 3 years before we actually moved in. And this is what the property looked like, all 10 acres of it. And that's Cindy getting rid of all 10 acres of it. If you have a big invasive species problem, it does seem hopeless. Seems like you can't do it. She proved otherwise. She did do it. She cleared the 10 acres. Now we have to be vigilant. We have to keep after it, but she opened up a lot of spaces. And that's where I started planting oaks. There was a white oak about 1.5 miles down the road that dropped some acorns the year we moved in. So I gathered them up, I planted them, and white oak acorns germinate in the fall. So they put down a root, a radical, and that's all they do in the fall. And then in the spring, they put up their first pair of leaves, and that's all they do in the spring, and actually for most of the summer. And this gives people the impression that oaks grow really, really slowly. They're not growing that slowly. They're just growing underground. That first year, they're putting on 10 times more root biomass than above ground biomass. And then those roots will serve that plant very well the rest of the life and actually grow quite quickly, which we will see later on. So here's the little oak we're going to follow. This is in year 2. It's got a deer cage around it. If we don't cage an oak around here, you don't have it. We've got a real deer problem. And that's what it looked like 18 years later. It's 45 feet tall, 47-inch circumference, canopy spread of 30 feet. Still a baby, of course, but it's a real landscape tree, and it didn't take that long. One of the points I want to emphasize tonight is oaks are a lifeline to an awful lot of creatures. There are dozens of species of birds that depend on oaks, a lot of mammals, including rodents, but the big guys too. When we leave those oaks alone and they get big enough to have empty spaces, hollow spaces inside, that's where the bears overwinter. Raccoons, possums, not that many reptiles are associated with oaks, but there's several species of butterflies that are specialists on oaks. Hundreds of species of moths depend on oaks, as well as their predators and parasitoids. And we've got a lot of cynipid gall wasps that are making galls on our oaks, many beetles, June beetles, longhorn beetles, metallic wood-boring beetles, weevils. Then you look under the tree and you've got a lot of spiders, dozens of more species of arthropods and mollusks and annelids that are depending on oak leaf litter. So you're talking about a very complex community of living things that are associated with oaks. And the problem is most people don't know that. That entire community goes unnoticed. And if it's unnoticed, it's unappreciated. And if it's unappreciated, it's usually unprotected. And that's why I wrote The Nature of Oaks. It is a month-by-month guide to the life that you are likely to find on any oak that is on your property. My goal was to provide the knowledge that might lead to interest in oaks, and interest often leads to compassion. And I think we need a lot more compassion towards the natural world today. So first, a few facts. The genus Quercus contains 91 species in North America, 435 species globally. So for a tree genus, it's a big one. There are 200 species of oaks in Mexico alone. Quercus comes from the Celtic quer, meaning fine, and ques, meaning tree. So oaks are indeed fine trees. There are 4 major taxonomic sections in North America, and we hear these names often, so we'll talk about them. There's the white oak group, that's Quercus. The red oak group is Lobate. The live oak group is Verentes, and a much smaller canyon oak group, Protobalanus in the west. And in Texas, you have all 4 of those groups. This is the distribution of oaks in North America. There are oak species in every place except where it is brown. So in the high plains and the northern Rockies, we don't have any oaks, and down in the Rio Grande Valley, we don't have any oaks. But every other place we've got oaks. The center of distribution, of course, is the southeast, but California's got 38 species of oaks, so there are a lot of oaks all over the place. Oaks live a lot longer than we give them credit for. The average lifespan of an oak is 900 years. 300 years of growth, 300 years of stasis, and 300 years of decline. And during each one of those periods of growth, they're delivering unique ecological services to the landscape around them. We'll talk about why most of our oaks don't actually live 900 years. It's because of the way we treat them. What's the oldest oak in the country? It could be the Penchenka oak, a coastal live oak in California, estimated to be 2,000 years old. But if you're really looking for the oldest oak, you want to go to the slow, low growing oaks. They're almost like ground covers. The Palmer oak is one, also in California. It roots its way along, roots here, then grows for a long time. Then it'll die here and be growing over here. So this one's been estimated at 13,000 years old. Some of the oldest things on the planet are actually oaks. They can get big. This was the Y oak, the largest white oak in North America, in Y, Maryland. I got to see it before it fell over in a hurricane about 20 years ago. It was a big fella, But another thing I'm gonna mention today is that not all oaks are big, and there are actually a number of options of oaks that are quite small that we can get into small landscapes. And then finally, we're gonna stress the fact that oaks have superior ecological function. They have the highest biodiversity value, meaning they are supporting more species than other trees. They're sequestering more carbon dioxide, pulling it out of the atmosphere, and then building their tissues out of the carbon, which they hold above ground for a long time. But they're also pumping carbon through their root systems into the soil. And that's really a valuable ecosystem service, because once it's in the soil, it's very stable, can stay for thousands of years. Our soils are brown or black because of the carbon that plant roots have deposited there, and oaks deposit a lot. They're some of the best soil stabilizers we have because of their big root systems. They make the best leaf litter, meaning it lasts the longest, and all of that promotes healthier watersheds. So I started the book in October, and people always want to know why I started in October, because that was when my wife Cindy said, "Why don't you write a book about oaks?" I said, okay. It was October, and I looked out the window, and that's what the oak looked like. Of course, October is when we are really noticing those acorns that are falling. Acorns are one of the most notable parts of oaks, and they can make a lot of acorns. A single oak can make 3 million acorns in its lifetime. And each one of those acorns is a rich packet of food that nourishes lots of wildlife. It's very high in fat, very high in protein, and many creatures depend on them. Again, rodents depend on acorns when they fall, but so do the big guys. The black bears are running around the woods, eating as many acorns as they can to build up winter fat. And of course, our squirrels and those cute deer we all love. But turkeys doing the same thing, putting on as much fat as they can from acorns in the fall. Red-bellied woodpeckers, titmice, towhees, nuthatches, flickers, they all love acorns, and so do ducks, particularly wood ducks. Any acorn that is viable when it hits the water will sink. So the wood ducks swim down and they get those acorns, and they actually come up on the land and eat acorns as well. There are lots of invertebrates that eat acorns. This is one of the most common ones, the acorn weevil. Here is the larva tunneling out of an acorn, and there's the adult acorn weevil. They can be really common in acorns. And then another group of insects, acorn moths, they're doing the same thing. The caterpillar develops in the acorn, then it comes out and it becomes a moth like this. There's actually several species, but they look so similar, we need DNA to separate them. So you have all those things eating acorns, and if you look under a tree maybe 2 weeks after they drop their acorns, it's utter destruction. You can't find any viable acorns. They're eaten, they're crushed, they're carried away, and you might wonder how oaks ever successfully reproduce. And this is where a very ancient mutualism between jays and oaks comes to the rescue. Both lineages, both oaks and jays, evolved in what is now the Arctic 56 million years ago. And immediately they started to like each other. They liked each other because they give each other important services. Jays get winter food in the form of those acorns, but jays also allow oaks to move, to disperse farther and faster than any other tree genus in the world. And this is how that works. Jays store those acorns for winter food. They don't cache them, so they're not making a pile in one place like many squirrels do. They bury them singly in different places. So they will pick up an acorn, they'll fly, up to a mile, although I just read yesterday, it's 1.5 miles. I don't know. It's a long distance from the parent tree. Then they tap that acorn beneath the soil surface, wherever it's soft enough to do that. Now, if they think another jay has watched them bury that acorn, they'll wait a few minutes and they'll dig up the acorn and move it someplace else, because jays know that jays steal acorns. And then, of course, during the wintertime, they're going to go back and find that acorn and have something to eat. During the fall, they work really hard. A single jay can bury 4,500 acorns each fall. But they only remember where 1 out of every 4 acorn is. So for every 4 acorns they bury, they've actually planted 3 oak trees. That means a single jay can actually plant 3,360 oak trees each year. And if they do that 1.5 miles from the parent tree, that's what allows those oaks to move farther and faster than other tree species. It's not just blue jays that are doing this. All the jays do it. The This is a scrub jay in Oregon doing it, but your green jays, got about, what, 7 or 8 species of jays in this country, and they all have a relationship with oaks. So do acorn woodpeckers, a beautiful bird in the Southwest. They're depending on acorns as well for winter food, and they store them in the same way, but not in the same place. Acorn woodpeckers like to store their acorns in holes that they have carved in what we call an acorn tree. Just a dead snag, and they carve a bunch of holes in there, and then they store their acorns over the winter time. But it takes a long time to carve one of these holes. It's a lot of work. So once they've carved it, they protect it. Family units protect an acorn tree because it's an extremely valuable resource. They have up to 50,000 holes in a single acorn tree, and they use it for generations. They don't want any other acorn woodpeckers using it, so they'll guard it jealously. And if you end up with an acorn tree in your yard, it becomes enormously entertaining. Okay, November is when you might look back and say, well, there were a lot of acorns this year, or not very many. But usually it's not much in between. It's all or nothing. And when they make a lot of acorns, we call it a mast year. Typically members of the same taxonomic group will make acorns at the same time. And then other years they make practically none. So that's a curious reproductive behavior, and ecologists want to explain it. There are 4 hypotheses that ecologists favor right now. And they're not mutually exclusive. They all could be operating at the same time. Predator satiation, predator reduction, improved pollination, and energy partitioning. So predator satiation, this is an acorn weevil outside of the acorn. And as I said, they can be really numerous. 90% of the acorns on a tree can have an acorn weevil in it. Now, if oaks made the same number of acorns every year, the way many other trees do, the population of acorn weevils, of squirrels, of deer, of turkeys, of all the things that are eating those acorns would stabilize around that number, and they'd eat all the acorns. But if oaks vary the number, so if they make a whole lot of acorns one year and a mast year, and then almost none the next year, then you get starvation of all those acorn predators, predator reduction, and usually it goes several years with very few acorns. So the populations of squirrels and turkeys and everything else remains low. Then you have another mast year. And they produce more acorns than the acorn eaters can eat, and that is predator satiation. Improved pollination. Oaks are wind pollinated. They drop catkins that look like that, and they simply release their pollen on the air. And that, of course, is a game of chance whether or not the pollen finds the female flowers, tiny little structures that are actually not maturing at the same time the pollen on a particular tree is released. And that's why oaks cannot self-pollinate. They need the pollen from another oak of the same species, although they can hybridize. And if you get a whole bunch of oaks releasing their pollen at about the same time in a mast year, then the chances of successful pollination are increased. And then finally, energy allocation. And by the way, if you're wondering whether oaks can have good fall color, they can. This is a scarlet oak in my front yard. There's never enough energy to go around. So oaks partition it. They either spend most of it on growth or most of it on reproduction, but rarely do they do both at the same time. So as I said, these 4 hypotheses are not mutually exclusive, and they all could be operating to explain oak masting at the same time. December is when you might recognize another curious behavior that oaks exhibit, and that is that they don't drop their leaves. At least members of the white oak group, and particularly younger trees in the white oak group, they hold their leaves right through the winter. This is called marcescence. And again, curious behavior for a deciduous tree. Why are they holding their leaves? So again, ecologists try to explain it. And the leading explanation is that it wasn't that long ago, 8,000–9,000 years ago, that the world was full of large Pleistocene mammals. They did not disappear right after the glaciation. And so this is the number of large mammals that was in Mexico alone. 3 species of mammoths. There was the giant sloth that could reach up 18 feet. There were 44 species of rhinoceros in the world back then. So many of these large mammals were browsers, just like the white-tailed deer. So not out eating the grass in your yard. They were eating buds. They were eating woody material of next year's growth. And they really like the nutritious buds. So if oaks surrounded those nutritious buds with the dead leaves of the previous year, it made them not so tasty anymore. It was difficult to get a bud without getting a mouthful of dead leaves. And the distribution of marcescent leaves supports that hypothesis because they only go up about 18 feet. And above that, there's no need to protect those buds because those mammals couldn't reach it. Impossible to test that hypothesis these days, but it makes a nice story. And marcescence also gives oaks a landscaping trait that other deciduous trees don't have, and that is you can use them as a screen. So if you don't like your neighbor and you want to screen them out, plant a white oak and it will do it all year long. January, cold, at least it is up here, and most people are not out staring at their oaks, but if you do go out and stare up at your oak, you often see small birds, tiny birds flitting around the tree. You might not think much about that, but you're looking at chickadees, you're looking at titmice, you're looking at golden crowned kinglets. I took this picture of a kinglet in my backyard when it was snowing. So now chickadees and titmice are birds that are feeders all winter long, eating seeds. 50% of their diet is seeds. The other 50% is insects and spiders. So maybe they're up in the tree to get the insects and spiders. But, you know, there are no leaves up in the tree. We know there's no insects and spiders up there. And the golden crown kinglet doesn't make any sense at all because it's a tiny bird. It's even smaller than a chickadee, and it doesn't eat seeds at all. So 100% of its diet is insects. And it should have migrated. It should have migrated to where insects are more common, but it doesn't. It stays up north, and that forms the kinglet paradox. What is a bird that needs insects all day long doing up north where there are very few insects? Well, Bern Heinrich does not like paradoxes. He writes the natural history column for Natural History magazine every month. He's a retired entomologist, but a great natural historian. And he actually looked in the crops of golden crown kinglets in Maine in January, and he found they were full of caterpillars in Maine in January. So obviously there are caterpillars out there on those trees. There are a lot of caterpillars on those trees. They just look like sticks. So we didn't actually know they were there. When it gets really cold, when it gets below freezing, there are antifreeze proteins that keep the cells of those caterpillars from bursting. So they shrink a little bit. And then when it gets warmer, they swell a little bit. But those caterpillars just sit there all winter long. And that's the next question. There's no more kinglet paradox. We know why they're there. There is something to eat. But what are the caterpillars doing here? There really is nothing to eat for the caterpillars. They just sit there all winter. And again, we don't really know. But this is what I think is going on. Of course, in the spring, you've got those buds bursting out. Most insects overwinter as eggs. Or they overwinter as pupae or chrysalids, or they overwinter as adults. Fewer overwinter as adults, but very few overwinter as larvae. If you overwinter as an egg, when you hatch out, you're a tiny little guy. So those big caterpillars can outcompete them and have access to all the food they want. If you overwinter as an adult, you've got to find a mate. You got to mate and then lay eggs, and then those eggs hatch, and so on. So the caterpillars, if they make it through the winter without being eaten, are in a great position to have unlimited food supply in the spring because they can outcompete any other insect. February is the quietest time of year for oaks. So it's a good time for me to talk about what I call oak landscaping myths. Now often, well, I hear these things all the time. I hear that oaks are too expensive. They grow too slowly. People aren't going to live long enough to enjoy their oak. They're too big to use on small lots. If we do use them, they're going to fall over and crush our house, or they're going to lift up our sidewalk or our driveway. I call them landscaping myths, but there are facts often associated with myths. So let's talk about fact or fiction for each one of these. For example, are oaks too expensive? Well, they can be if you insist on instant gratification, if you insist on planting a big oak, and many people do. People do not want to wait. So nurserymen have figured out how to grow trees in little pots without having the pot without the roots becoming root bound. You certainly don't want to buy a tree where the roots go around and around. That is root bound, and those roots will continue to go around and strangle the tree, and it will not live very long at all. But these are called air pots, and it's technology that allows us to grow plants without root binding, but you still have a very small root mass compared to the size of the tree that is in that pot, which means once you plant it, the first thing the tree has to do is rebuild the root mass, and that can take a whole decade. I came across this planting in Newark, Delaware, a couple summers ago, 10 oaks, big oaks, and every single one was dead. That's a lot of money down the drain. So we have to be careful about planting those big trees. It's very easy to get it wrong. Here's another way that you can get it wrong, and that is through bald and burlap trees. Look, very hard on the trees because you've chopped off all the roots. So you've got a big tree that depends on a large root system, and it doesn't have the large root system anymore. So you plant it. If it lives, the first thing it's got to do is rebuild that root system. And again, that can take an entire decade. So if I plant an acorn the same day I plant one of these trees, and they can be expensive, you can pay $3,000 for one of these trees. In a decade, that acorn is going to be that size. Not really, but it is going to grow and be bigger and healthier and grow a lot faster than that bald and burlap tree because it's got a full complement of roots that was never disturbed. This is the angel oak, by the way, in, where was it? Johns Island in South Carolina. It's also a big fella. This is a perfect size to sell an oak or to plant an oak. And I'm not trying to kill the big tree industry for nurserymen, but I am trying to add this to that nursery. There are reasons that we want to plant big trees in streets and things like that. So that there will always be people that want big trees, but there's a whole lot of people that are very happy with smaller trees because they're cheaper. They can afford them. You could sell this tree for $5 with no problem at all. And it actually will be a healthier tree in the end. But then we run into the next question. Do oaks grow too slowly? Are we all going to be dead before we can enjoy our tree? Well, let's have a race here between my little friend Bella and the oak that we're following. It's 6 years old here. It's a white oak. So you know white oaks grow really slowly. And Bella's 2 years old here. So maybe she can catch up and pass this oak. We're going to have a race here. Bella is not my daughter. She's not my granddaughter, but she was our surrogate granddaughter before we found some real ones. So here it is, 6 years old, 7 years old, 8, 9, 10, 11, Bella's losing, 12, 13, 14, 15, 16, 17, 18, 19, 2020, Bella's 16 years old. The tree is 20 years old. Bella has lost the race, but she tried hard. She's 5'11". But it proves once you get that oak going, it grows as fast as anything else. It's a real tree. So that I'm going to call that a complete myth. Oaks do not grow too slowly to use as landscape trees. And this is a really important point. Even as tiny little things, they will contribute to your local food web, which is one of the major reasons we're planting oaks. They contribute so much ecologically. This is a pin oak that's just popped its head above the leaves, and here's a caterpillar standing on the ground eating the leaves of that tree. The very first year, you don't have to wait decades or hundreds of years for your oak to start to support your local wildlife. It will do it right away. So caterpillar's eating it, but a bird's going to come and eat this, and you've got a real food web. Are oaks too large to use in small yards? Well, you're not going to get anybody to recommend a large oak for a small yard these days. But, in the old days, they did. These are two big red oaks. There's a whole street of big red oaks and pin oaks in very tiny yards that I pass when I go to the university. And then they're probably planted the same time these houses were built, which was probably 100 years ago. Now, remember, 100 years ago, there was no air conditioning. So these oaks provided a very valuable ecosystem service. They protected them. They lowered the temperature of those houses by 10 degrees in the summertime. And look, they have not lifted up the hardscape. They didn't touch the sidewalks or the street, no problem at all. They have not fallen over on the house and crushed them. But again, nobody's going to recommend that these days. This is a big oak in front of a big church. Unfortunately, they did not cut it down when they built the church. This is a big Gary oak, the Oregon oak in Portland, Oregon. a very big fella in a small yard. So you can find these cases where you have a big tree in a small yard, but nobody's going to recommend it. Point is, we've got small oaks, and the yellow ones that are highlighted here are all the species of small oaks that occur in Texas alone. So you got a lot of options here. In the East, we don't have as many, but still enough. The very important one that we use a lot is the dwarf chestnut oak, Quercus prinoides. There's a dwarf live oak, Quercus virginiana minima. That's the southern live oak that has all the Spanish moth hanging from it. But look at all the options you have. Now, not all of these are in the trade, but they could be. We've got to ask our nurserymen to get these guys in the trade so we can plant them even in very small properties. This is my dwarf chestnut oak. One of them produced acorns when it was 5 feet tall. Here's another option that I'd love to have people try. Beavers try it all the time, and it works. It's coppicing. You let your oak get maybe 3 or 4 inches in diameter, cut it off at the base, and it'll come back as a bush. And you can do that for centuries, and it'll stay a bush. So you get the benefits of oak foliage in your yard without having a very large tree. So this is an option for small yards. I found this picture on the web. So I haven't found anybody who's actually done it. But I said beavers. If you go to a beaver dam and with a house and you look around, they have cut the trees down right down to the bottom, to the ground, and they come back as coppice. So you get to see what it looks like. Are oaks going to crush our houses? They could. Sometimes they do. And if they do, it's not just oaks, any big tree, you will hear about it on the news. There's a rule in the news that they cannot report good news. It's got to be bad news. You will never hear about the oak that did not fall and crush your house. So why are they doing this? Does it really mean that we can't plant these big trees? Our trees are falling over because of the way we plant them. We plant each one as a specimen tree. They're all isolated, so they don't get to interlock their roots with any other tree. And when you get a big wind and a lot of rain, over they go. This is the way trees grow in a forest. They grow close enough together that their roots are intertwined, and it's a very strong matrix. Almost impossible to blow them over when they're in a matrix like this. You can get a tornado, it'll snap them off, and there's nothing we can do to protect against tornadoes. But here's a stream cut near my house. 1, 2, 3, 4 trees where the roots are really interlocked, extremely stable plantings this way. So rather than this, let's consider this. These are the 2 white oaks that I got our original acorns from down the street, 3 feet separated here. Nobody planted them. They planted themselves. Well, maybe a blue jay planted them. I put the road in afterwards. Now, neither one is as big and spectacular as it would be if it were planted alone, but they're still there. They have not blown over. Their roots are interlocked, much more stable. Here's this is called the Three Sisters in Northwest Connecticut, 3 big red oaks. If you walk in the woods, you will see this all the time. Big trees growing right next to each other. This is a planned landscape at Mount Cuba Center in Hockessin, Delaware. It's one of the DuPont estates. Big red oak in the background here, hemlocks in the front, big rhodies down here. But it doesn't look planned. It looks totally natural. There's even hardscape down here. If you have a property where it's got 4 or 5 acres of lawn, you say, well, gee, I want to reduce that. This is a great way to do it. Build a tree grove. They do not have to be the same species. You do want to plant them when they're young so that their root system can intertwine as they're growing. But you will form good habitat and a very stable and very beautiful part of your landscape if you create tree groves like this. Are oaks going to lift up our hardscape? They can, depending on what you plant them over. If you plant them over bedrock, there's no place for the roots to go except laterally, and they will lift up hardscape. This is a pin oak that's planted not over bedrock, no problem at all. The roots go deep underneath the road there. These are 2 big red oaks at the University of Delaware, right next to the curb, no problem, because there's enough space. Another thing that you want to watch out for is, even if you don't have bedrock, if you're in an area that was once a farm, an old agricultural property where the plow went down maybe 15, 18 inches for a century, 2 centuries, beneath the plow, the ground got compacted. That's called pan. And that can be really hard for roots too. They'll hit the pan and they'll go laterally. So if you know you're over agricultural pan, break it up. You can get there's a hook you drag behind a tractor called a ripper, and it'll break up that pan, or just get a pickaxe and break it up. And then your roots will go deep, and you'll have no problem with lifting up hardscape. Okay, March is when those marcescent leaves do start to drop, and they start to do what leaves do, and that is cover the ground. First, let's talk about the variation in oak leaves. A lot of variation in oak leaves. A lot of people think all oaks have lobed leaves, because a lot of them do, but many of them don't. This is a shingle oak. This is a chestnut oak, water oak. This is an emery oak in Arizona with leaves that look like a holly. Willow oak, southern live oak. So a lot of variation in oak leaves, and they make a lot of leaves, 700,000 leaves on a single large tree. And if you line them all up on a tennis court, it'll cover 4 tennis courts. And again, that's their job, to cover the ground. They do it well because a single oak leaf can last up to 3 years before it breaks down. And that's important because you don't want bare soil. So tulip tree leaves, birch leaves, maple leaves, many of the North American tree leaves break down very quickly. And if you don't have a mixture of oak leaves in there, you've got bare soil before the end of the summer. And that's very unhealthy for the soil community. Everything in the soil community wants high humidity, and that's what these leaves are doing. They're keeping the moisture in the soil, which is important because there's more species that live in the soil than above ground. So they're performing a really important ecosystem service. People worry, can our plants get through those oak leaves? Well, this is a fern. It's not a planting. Nobody planted, just a natural fern occurrence that is coming through the natural layer of oak leaves under this white oak here. No problem getting through. Nobody tending it. This is wood poppies in my yard coming through leaf litter. I'm never home. I don't have a chance to rake my leaves. So they're there and the plants do fine. This is native pachysandra going through oak leaves. This is Virginia creeper, great ground cover going through oak leaves. So many of our plants can handle normal layers of leaf litter without any problems. And they're teeming with life. In a single square meter of oak leaf litter, you can have 250,000 mites, 100,000 springtails, like this little columbulan, little sminthurid, 90,000 proturans. Those are primitive insects, very, very tiny, 1 million nematodes. And these guys are breaking down the leaf litter. They're returning the nutrients to the soil so the oak can use it again next year. That won't happen if you rake all your leaves away. You'll have bare soil, or you'll have to go out and buy mulch, but you're not going to return the nutrients that your tree just uses. That's one of the reasons our oaks don't live as long as they should. We typically take the leaves away from them every single year. And when you do that for 50, 60 years, it starts to add up. Then there are things that we really do appreciate that depend on oak leaf litter, like the banded hair streak, beautiful butterfly. That's what its caterpillar eats. Oak leaves, dead oak leaves. You'll never find the caterpillar in there, and you won't have the caterpillar if you rake it away. You won't have 70 species of what we call litter moths, things like the ambiguous litter moth, the American idea, the dark-spotted Palthus 67. Other species are depending on the leaf litter under your tree. If you watch your birds, if you watch your towhees or your sparrows during the wintertime, looks like they're doing a dance in the leaf litter. They're hopping. And what they're doing is pushing the leaves back, looking for the caterpillars and the pupae of these guys. And that helps them get through the winter. Only works if you don't rake those leaves away. And of course, there's a lot of predators down there that are keeping those populations in check. Many species of ground beetles. This is where our fireflies live. Fireflies, this is, they're not fireflies, they're not lightning bugs, they are beetles. That's what the adult looks like. There's its luminescent organ, but that's what the larva looks like. It looks like a little dinosaur, but it's a predator on mollusks, snails and slugs, sometimes worms in leaf litter. So you will only have lightning bugs if you don't rake all your leaf litter away. April. This is your chance to see one of the most ephemeral interactions in all of nature. Only lasts about 5 minutes a year. I'm talking about something that happens frequently on a lot of the buds on your oak tree, but I'm talking about when synipid gall wasps lay their eggs in one of the buds of your oak tree. which will expand and become a gall. So this is a female synipid galler. There's her ovipositor. She's injecting an egg into this bud. This is a male synipid that has fathered that egg. He's already mated with her, but he's riding her. He wants to be close by because after she lays this egg, she's going to go to another bud and lay another egg, and he wants to be the father of that egg too. This is a male who wishes he was this male. So she's injecting the egg, but she's also injecting plant hormones that will shape the growth of they're essentially stem cells, meristematic undifferentiated cells in our oak buds that can grow into any shape. But it's a compromise between what the galler wants and what the oak wants, because the oak has plant hormones too. People say galls are like cancerous growths. But I don't like that analogy because cancerous growths are uncontrolled growth. They just keep growing. Galls are highly controlled growth forms. So highly controlled that we can tell what species of galler made the gall just based on its shape because it's extremely consistent. A lot of species of gallers, 1,000 species of synipid gallers. A single tree can support 70 different species of gallers. It's very hard to find an oak tree that does not have a gall, at least one gall type on it. Many of these galls are hollow. This is the apple oak gall or the oak apple gall. I've seen it written both ways. And if you cut it open, you've got a central sphere in here, and inside that sphere is where the galler is itself. But then you got a bunch of air and then the outside of the gall. So what's that all about? Well, it turns out that synipid gallers have more parasitoids, more natural enemies, other wasps in lots of families. This is the family Tallamy, and those wasps want to lay eggs in the synipid galler. So they have really long ovipositors. And the position of the galler in the center of the gall has got to be greater than the length of this ovipositor from the outside of the galls. Otherwise, this pterimid wasp will be able to reach the galler and kill it. When the gall is very small, she can reach it, and that's when they're vulnerable, but those galls grow very quickly, and all of a sudden that space will protect the galler from that synipid galler. This is that pterimid galler. This is a pterimid in California, has the longest ovipositor, and it has created the largest gall in the country, in an effort to keep the galler safe inside, protected from that very long ovipositor. A lot of variation in gall size and shape. Many of them are round and on leaves or round and on stems. Some of them look like candy. Some of them look like that. Many of them look like plant diseases. Spindle gall, more candy galls. This one's looks like pottery in my yard. This is the cutest one I've ever seen, the gnome house gall in California. Brain gall. Here's an interesting one. There are 4 galls on a single oak leaf, and obviously the galler laid a number of eggs in a single gall. So these are exit holes. Each hole represents a galler that has emerged. So you've got one leaf making hundreds of adult synipid gall wasps. And galls have played an interesting role in the recorded history of humans. If you grind up a gall like this and combine it with particular chemicals, it makes an indelible black ink. And that is the ink we've recorded our history with for thousands of years. The Bible was written with gall ink. The Magna Carta was written with gall ink. The Declaration of Independence was written with gall ink. All of the scribes and monks and Leonardo da Vinci and all the people in the Middle Ages wrote with gall ink. So that's something you can share at your next cocktail party. May, this is when the new biological year really kicks off. And that's because all over the temperate zone, we have expansion of the leaves of deciduous trees, particularly oaks. And following the expansion of those leaves comes the caterpillar that eat those leaves. And following the caterpillars come the birds that eat those caterpillars. You Audubon people know this. It's no coincidence that our migrants have timed their migration so they arrive in North America when there's plenty to eat. Now remember, plants do not make berries and seeds in the spring. They haven't made them yet. So what the birds are eating primarily during their migration is insects. And most of those insects are caterpillars. Birders know where to look for warblers in particular. You go to the tree that's going to make the most caterpillars, and that is one of the oaks. Had a student look at the number of minutes that warblers forage in various tree families, big trees and cemeteries. So the first bar here is Fagaceae. That's the family the oaks are in, oaks, chestnuts, and beeches, but there were no chestnuts and beeches in her sample size. So this is all oaks here compared to pines and birches and so on. Obviously, the birds are spending the most time in the oaks, again, because that's where the most food is. That's where things are like the purple-crested slug, the buck moth, the white-marked tussock moth, the saddled prominent, double-lined prominent, white-dotted prominent, the checkered fringe prominent, the laugher, the lace-cap caterpillar, the two-spotted oak punky, the skiff moth, the white-blotched heterocampa, the oblique heterocampa, the variable oak leaf caterpillar, the banded tussock moth, the red-lined panapoda, the yellow-neck caterpillar, the smaller parasa, the unicorn caterpillar, the crown slug. These guys are called slug caterpillars because their head is tucked up underneath, not because they're really slugs. The streaked dagger moth, the epilated dagger moth, the lesser oak dagger moth, the greater oak dagger moth, the streaked dagger moth. No, the afflicted dagger moth. I'm sorry. The red-humped oakworm, the pink-striped oakworm, the confused wood grain, the spiny oak slug, and this is my favorite, the spun glass slug caterpillar, and literally hundreds more species are associated with oaks, and that's what those birds are after. So this is what our yard looks like today. Actually, the leaves are down today, but we put a lot of plants back. And my research has shown that you can count the number of moth species, the number of caterpillar species in your yard, and get a very, very accurate index of how productive that food web is and how stable it is. So that's what I've been doing for the last 5 years. I've been counting the number of moth species, haven't gotten to the butterflies yet, that are now making a living in my yard because I put the plants back, and I'm up to 1,196 species. That's a lot of species, and 28% of them use oaks. Now, only 1.5% of the plant diversity in my yard is oaks. So oaks are really important features in maintaining this website. And because so many of those caterpillars are types of bird food, we have recorded 60 species of birds that have bred in our 10 acres. Not flew by, but bred. And that's why I call oaks keystone species. They really are supporting more than other trees. Remember what a keystone is. It's a stone in the middle of the arch, the Roman arch. If you take it out of the Roman arch, the arch collapses. Well, if you take keystone plants out of your local food web, the food web collapses. Just 14% of our native plants are making 90% of the caterpillar food that drives those food webs. And oaks are the best keystone plant in 84% of the counties in which they occur. They support over 950 caterpillar species nationwide. No other plant genus comes close to that. Keep talking about caterpillars. Who cares? Why do we need so many caterpillars? Well, caterpillars are transferring more energy from plants to other animals than any other type of plant eater. So if we design landscapes that don't have a lot of caterpillars in them, we've got failed food webs and eventually failed ecosystems. And don't forget the birds that do not migrate, the ones that are spending the winter here, they're also reproducing here, and they need a lot of caterpillars too. Carolina chickadee, for example, needs 6,000 to 9,000 caterpillars to make one clutch. That's just to get them to the point where they leave the nest. And after they leave the nest, they continue to, the parents continue to feed them caterpillars for another 21 days. But they're flying all around, so nobody's been able to count them. But you're talking about tens of thousands of caterpillars to make one clutch of a bird that's 1/3 of an ounce, 4 pennies worth of bird. And of course, we want complex communities of birds. Who's going to make all those caterpillars? Oaks will make more than any other plant. Okay, June this year at our house, June was when we had the emergence of the periodical cicada. Pretty sure you guys did not have that, so we'll talk briefly about what happened. It was an exciting time. We had the 17-year brood, and it's very predictable. We know exactly when they're going to come out, which means the media got to try to scare everybody to death. That's their job. They said it's going to be a terrible scourge. We should all fear it. You might consider moving before you have to experience this terrible thing. It's an invasion. The cicadas are going to sing so loud that you will go mad and kill your babies. I heard all these things on the television or the radio. Of course, none of that is true. It really is one of the most fantastic biological events that you'll ever be privileged to witness. And it was a big one. This is the shed skins of the cicadas just outside, next to an oak outside my building at the University of Delaware. Of course, once they emerge, they have been feeding on xylem on plant roots for the last 17 years. And then synchronously, they crawl up through the ground and they aerate the soil. In other words, they allow oxygen and water to get down to the roots. It's a valuable ecosystem service for free. And again, a lot of them, so many that 11 Mississippi kites flew up to Newark, Delaware to eat our cicadas. And they stayed for 2 weeks. I don't know where they came from, but that was fun too. So here's the life cycle. They come out at night, they hang upside down, they split their skin, they swing down, then they hang from that skin. It's called an exuvii. And at this point, they're like a soft shell crab. Lots of things can eat them, which is why they do it at night. So they hang there until they harden up, till they tan their exoskeleton. And once they do, they're ready to start their life cycle. Now, if you're a male, you fly off to a tree and you sing as loud as you can. By singing, they've got 2 membranes in their thorax called tympana. And they vibrate them, but it's really like a clicking a Coke can, click, 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 click. Only they do that about 400 times a second, and that creates a buzz. And they want to buzz as loud as they can because female cicadas will go to the loudest male. They're choosing male quality based on how loud they can sing. And this one sang loud enough. A female came, they mated. Now it's the female's turn. She's going to lay eggs. In this case, this is a stem of a pin oak in my front yard. That's her ovipositor. She's jamming it into the stem to lay an egg. That's hard to do. Get a pin and try to stick it into an oak stem and see if you can do it without bending the pin. She can do it. She gets her ovipositor all the way in there, lays an egg, then she goes right down, 3 or 4 or 5, 6, 7 eggs in a row, and then she'll move to another stem and do it again. And from the point where she lays her eggs on out, the branch often dies. That's called flagging. And people get upset, oh, the cicadas are going to kill my tree. They're not going to kill that tree. You're going to prune your tree once every 17 years, and that's okay. The eggs hatch, the little guys fall to the ground, they tunnel under the ground, and they start to feed on the xylem of plant roots. The xylem is just like water. There's almost no nutrients in it at all. So you can have 50,000 cicada nymphs on the root system of a single tree with no measurable impacts on the health of that tree. I had a student look at where those cicadas were ovipositing in Newark, Delaware. The green bars are species of oaks, and we did it by looking at where the flagging was. So they used lots of trees, but they used oaks more than anything else. And then they die. Takes about 3 weeks, and that's it. You won't see them again for another 17 years. So what are they spending 17 years underground? It's probably predator satiation, just like we saw with, what do we see it with? When we talked about predator satiation. A lot of things eat cicadas, the squirrels and the birds, but there are never enough squirrels and birds around to eat all the cicadas. Nothing can wait 17 years for its next meal. So the predator populations cannot depend on reliable cicada populations. So when they come out, they easily swamp the number of predators that are available. July, it's when the night chorus begins. And by that, I mean when katydid starts singing. This is a male katydid. He's going to raise his front wings and rub them back and forth against each other. This is a sclerotized part of the wing, and there's a scraper and a file there, and it will make a typical katydid sound. So why are katydids singing? This is why. Once upon a time, there was a young woman named Katie who fell in love with a handsome young man. Alas, he did not share her feelings, and he married another. Soon thereafter, he and his young bride were found poisoned in their bed. Who perpetrated the crime was never determined, but some say the insects in the trees were watching that night, and each summer they solved the mystery by singing katydid, katydid. You probably all heard this. I grew up I did a lot of camping in North Jersey when I was young, and katydid sang me to sleep many a night. I love that sound. There are 4 species of katydids that frequent oak forests. from Texas on eastward. When you move farther west, they drop out. There's only one species in California. This is what a female looks like before she's mature. Her wings haven't expanded yet, but her ovipositor is ready to go. And here her wings have expanded. So she's going to go looking for a male, and she's going to look for the loudest male. That's why they're as loud as they can be. Again, she's judging male quality. A male cannot sing loudly unless he's healthy and large, and that's what she wants. When she mates, she will lay her eggs, and she just glues them to the side of twigs here. These guys have already hatched, but sometimes people find them. They're usually up in the canopy. And when they find them, they wonder what they are. Okay, August. Now, katydids will start singing, at least in my neck of the woods, around mid-July. They will sing through July, right through August, into September, until it starts to get cold. But speaking of August, it's when oak leaves become really, really tough. And it's tough for things to eat oak leaves. In the spring, of course, they're soft and they're tender. They're very nutritious. Lots of things are eating oak leaves in the spring. But by August, they're like boards. They're full of tannins, full of lignins, very difficult to eat. But insects that eat oaks have come up with a couple of adaptations to be able to get around this toughness, and feeding gregariously is one of them. This is the yellowneck caterpillar. And it eats in a group when it's young, and it eats in a group when it's older too. And it allows them to get through that tough leaf material much easier than if they were alone. This is the orange-humped oakworm. So the pink-striped oakworm. Gregarious feeding is very common in oak caterpillar specialists. But they can eat a lot of material, and people find these groups of caterpillars and they get all upset. I walked around our oak here at the end of July in 2014, and I counted the number of caterpillars that were just within head height on the oak tree on that one day. And there were 410 caterpillars, and 115 of them were those large yellowneck caterpillars eating a lot of leaf material. But then I stood back and I took that picture so I can ask you, how much caterpillar damage do you see? How many caterpillars do you see? You don't see any. And this is the distance at which we view our trees. But if I knocked on your door and said, you got 410 caterpillars on the lower part of your tree, most people would freak out and say, call the man, get the spray can, save the tree. You don't have to save the tree. Oaks are really good at sharing the energy they've captured from the sun. And if they didn't share the energy, you wouldn't have a viable food web, and you wouldn't have anything else in your yard. I met a woman in New Orleans, Tammany Baumgarten, several years ago, who suggests that we all practice the 10-step program. Take 10 steps back from your trees and all your insect problems disappear. I think that's great advice. Another example of how to get around tough leaves is to become a leaf miner. You only eat the inner part of the leaf that is not tough. So the toughness is in the epidermis, the upper and lower epidermis. So insects have done that, particularly little moths, tiny little moths. The egg is laid here, and this is a serpentine leaf mine. The caterpillar is crawling around between the layers of the leaf, eating the leaf. The black line is its frass, its poops. He pushes it all to the center, then he pupates here, and that's all the part of the leaf he's going to eat before he matures. This is a blotched leaf mine. There's the caterpillar in there, and he just goes in a circle. Here it is backlit, and here it is with a very nice picture by Salvador Vitanza. Doesn't look much like a caterpillar because it's got to be so specialized to become a very thin leaf miner. But when it comes out as an adult, it does look like a moth. This is one of the Chamameria species on oaks, the solitary oak leaf miner, gregarious oak leaf miner, the oak tentiform leaf miner, many species of leaf miners on oaks. All right, September, our last month. This is when you're most likely to run into crickets, those black crickets on the ground. And remember, if one gets in your house, it's good luck. So don't kill it. But there are bush and tree crickets that are not black. They're usually yellowish, greenish, sometimes light brown, that are up on vegetation, including our oaks. And the males are doing the same thing. They're trying to attract a female by singing as loud as they can. But these guys are really smart about it. They will find a hole in a leaf, or they'll chew a hole in a leaf. They stick their head through there, lift their wings up, and move them back and forth and make their little cricket sound. Now, most leaves have a slight parabolic shape to them. So when they do it this way, it actually projects the sound farther and louder than if they sang on a flat surface. So they're sending a false signal a false message to the female. They're saying, I'm bigger than I really am. If you could believe a male would send a false signal to a female. So the female comes and mates with him, and you might say, well, gee, that's too bad. She's a loser. But maybe she's not a loser, because she might not be mating with the biggest male, but she might be mating with the smartest male. August is also, or September is also the time you're most likely to see walking sticks. They spend most of the summer walking around the canopy of trees, so we don't see them. But of course, they're called walking sticks because they look like sticks and they walk. This is one that was down low on an emery oak in Arizona that I saw. This is the species that's very common in the East where I live. They really do look like walking sticks. So they tend to come a little bit lower in September. But through most of the year, the females are walking along in the canopy, and they're dropping eggs to the forest floor. No care at all. They just drop into the forest floor. Some of those eggs hatch this year, some hatch next year, and some hatch the year after that. That's called bet hedging. They're not synchronized hatching, just in case conditions aren't good in one of those years. And they have a very curious behavior, or very curious interaction with ants on the ground. So here's the story with spring ephemerals. This is a bloodroot, and of course, bloodroots make pods, and inside those pods are very attractive little seeds when they break open, pretty little things, and they've got white structures on them called elaiosomes. Turns out that elaiosomes are really tasty to ants. So ants come along, they'll pick up the seed, they'll carry it back to the nest. Everybody eats the eliosome. The seed is too hard to eat, so they throw it in their garbage dump, which is about 1 inch below the surface of the soil, and it's a perfect place for that seed to germinate. Well, this is what walking stick eggs look like. They've got a white stripe there, just like an eliosome. I'll bet there's some chemical mimicry here, because the ants seem to think that they are seeds. They pick them up, they carry them back to the nest. They can't eat them, so they throw them in the garbage dump, and it's a very safe place for these walking stick eggs to hatch. Okay, we have made it through the year, talking about just some of the things that occur on the oaks that you may have in your yard, or that you're going to put in your yard. So let's end by talking about what we started with, and that is the biodiversity crisis that is plaguing the planet right now. We've got two major problems. We've got climate change, of course, but we've got a biodiversity crisis. And if we had no climate change, we would still have a biodiversity crisis, because we are not sharing our spaces with the life that supports us. We hear about things disappearing. We lost 3 billion birds in the last 50 years. The insects are disappearing. There's no mystery to it. They're not disappearing. We're killing our insects. We're killing our birds. We're killing the nature that supports us. And that's why we are now in the 6th great extinction event that the Earth has ever experienced. So it's a global crisis, but it has a grassroots solution. It's one that you and I can address and actually make a difference with. And here's how. There are 4 things that every landscape has to do if we're going to reach a sustainable relationship with planet Earth. Every landscape has to capture carbon and store it. Every landscape has to manage the watershed in which it lies. Every landscape has to support a diverse community of pollinators, and every landscape has to support a complex food web. Pass the food on so we have animals out there to run our ecosystems. When you plant an oak, you're addressing each one of those vital ecological goals. You're capturing more carbon than other trees. You're managing the watershed better with those huge root systems and the big canopy that softens the hard rain. You're supporting a more complex food web, because oaks pass their energy on better than other plants. You're even supporting a diverse community of pollinators, even though oaks are wind pollinated. If you watch those catkins in the spring, pollinators are all over them. They're gathering the pollen. Now, they're not moving it to the female flowers, so they're not actually pollinating, but they are using the oak pollen to help them get started in the spring. Despite all those wonderful landscape attributes, though, our oaks are in trouble. The old giants are largely gone from our forests because we've used them for wood, or we got rid of them because they were in the way of agriculture. The percentage of oaks in our eastern forests has been cut in half in the last century because we've suppressed fire. Oaks like fire. And we've introduced a lot of challenges, a lot of diseases, sudden oak death syndrome, oak leaf, bacterial leaf scorch, oak wilt, pests like the gypsy moth, which is now the spongy moth, winter moth, All these things have really hammered our oaks. And what's hammering them more than anything else right now is deer overabundance, because any young oak that germinates is eaten by a deer. We've got very little oak recruitment in our forests. We also got habitat fragmentation that is separating our oaks to the point where the pollen can't reach another oak. So we have poor acorn production. And because of all those things, 28 of our 91 North American oak species are now threatened. 1/3 of the global oaks are endangered. The Oregon white oak, which occurs from Southern California all the way up through northern Washington, has lost 97% of its range. There are 2,300 species that rely on oaks in Great Britain that are now threatened because of the loss of oaks in Great Britain. So we humans live our lives out in a very brief instant of ecological time, and we cannot return those giant oaks to the forest during that time period, but we can start the process. And in no time at all, those oaks will get big enough to start performing many of their really important ecological roles, assuming their keystone positions in our landscapes and in our natural areas as well. Every single person on the planet has responsibility towards good earth stewardship, because every single person on the planet depends on good earth stewardship, depends on healthy ecosystems. And the best way to exercise our responsibility towards that earth stewardship is to embrace the power of oaks. So for the sake of turkeys, of chickadees, of woodpeckers, of warblers, of jays, of thrushes, of our lightning bugs, of our galls, of our weevils, of our orthopterans, of our lepidoptera, our moths, of us, for our own sakes, plant an oak, plant a living community, plant the future. Thanks very much. But before we go, let me say a little bit about Homegrown National Park. Patsy gave a great introduction in the beginning, but this is our small nonprofit, which is designed to get the message that everybody is an important future of conservation. Everybody has a role in that. We want that message to go viral, and we're trying to use social media to do that. We're encouraging people to get themselves on the map, register their property on the map. It's free. What you do is you put down where you live and the amount of your property that you're going to be a good steward of, the area you're going to be a good steward of. What we're asking is that if you have a lot of lawn, we want you to reduce it, to plant more natives than you normally have, remove any invasive plants that are on your property already. Most people do have invasive plants on their property. Protect natural areas that might be associated with your property. Homegrown National Park's product is national awareness, not just of what the problem is, but what the solution is and what your role in that solution is. We're trying to change the culture, get everybody to recognize that nature is not optional. It is essential. And everybody has responsibility to sustaining it. And that map is going to provide measurable progress towards the UN's 3030 goal, saving 30% of the earth by 2030. If we don't look at what's happening on private property, we're not going to make it. Benefits are it converts hope to action. People talk all the time, I talk all the time, but we've got to move that to action. It doesn't rely on governmental support. We would love governmental support, but we don't need it. It merges national conservation efforts that already exist. Because we don't charge, we're not taking people away from Audubon or National Wildlife Federation or Wild Ones or anybody else. We're combining all those conservation efforts into one visual. What's happening on that map. And when we have the map fully developed, we'll be able to see holes in the biological corridors that are connecting the natural areas that currently exist right now. So that's what Homegrown National Park is all about. So thanks very much.
My goodness. I feel like I've been in a big wind. It's just so much going by and it's just so interrelated. It's just fascinating. Thank you so much. We had several master naturalists in training who came to this presentation, but they also had a class at 7:30. So I'm glad that we're recording it so they can watch it later and get the part that they had to miss. But they are very appreciative of what you are espousing. This is what part of what Master Naturalist teaches. let me go back to the beginning here, and it says, how can we get developers to keep from stripping trees from the land to build houses? Well, what would you say to that?
You can encourage laws to be passed in your township that controls what the developers do. So, you are not allowed to do that. You can build. It's a little bit more expensive to build without cutting all the trees down, but it can be done. People are doing it all the time. They can actually sell those properties for more. So there's financial incentive to do it, but it's a matter of making this type of stewardship a priority. The developer has, right now they have free rein that they can do anything they want. So we just have to make it known to our leaders that this is really important to us, and let's put some regulations on here. I don't like top-down regulations, but this is a good case where we need them.
Yeah, we have some places where we do bird surveys that we arrive one morning, and in a week all the vegetation had been removed, down to rock, and we have a lot of that in the hill country. We're on limestone, but they do it in the night and they do it in wholesale. But I think the other thing that what would you say to the idea that if you get a piece of property that has been stripped, in a way that's a blank canvas too?
It's true, you can put it back. Be nice if you didn't have to, but this is what we're talking about, putting it back.
Well, and your suggestion to use smaller plants. Now, my husband, who's sitting right over here, has a rule. We have to plant anything in our yard, you have to get a digging stick. It's rock. You're planting it in rock. Okay. So you have to have the plants that can live in that. But that forces us to go for smaller plants. And you don't have to get those huge things. You just get something going. And like you showed, it doesn't take very long for them to start producing enough to get that ecosystem kick-started. Right, so right. I really appreciated that. And I'm sure my husband did too.
My experience with volunteers, like you plant an acorn, they grow so much faster and so much healthier than what you buy.
Yep.
And here's a related question. Ways to manage little oak saplings in my flower beds. How do you go about, well, first, we have a lot of deer too in our place, but how do you, to what point do you nurture them before you transplant them into an area where they can actually develop?
I think the key is transplanting them as soon as you can, because they're putting down root systems. They may stay small for a while, but you want to get them, if you can get them that first year, that's ideal. I have transplanted things successfully even 3 years later, but it's a bigger job. And you inevitably have to disturb the root system when you wait that long. So as soon as they come up, move them.
Yeah, and a lot of people here use a lot of mulch, to preserve the water. And then they're raking their leaves and throwing them away and buying mulch. Hello.
Yeah. Yep.
It's an education thing. That's my thing is education. And we just need to talk to people about it more. Okay. And then we have a really wonderful comment here. I wish I could share a picture of my backyard. I've totally redone it based on Dr. Tallamy's suggestions on the benefits of native plants in yard. And when you, like your wife clearing those 10 acres, I'm sure she's thankful every day that she did it. Probably glad that she did it then rather than now.
Yeah. Well, she's still after it because the little guys come in, but it's easy to get rid of the little guys compared to those big ones. So,
and I think putting a sign in your yard, and these are all natives, and let people know. I think people confuse the native plant look with the vacant lot look, and a lot of neighborhoods don't really like that.
Well, this is why I say reduce the area of lawn, but don't get rid of it. Lawn is a perfect cue for care. You have at least a mower's width of lawn along your driveway and around your beds so that people know that it's intentional. Keep that lawn manicured so that you are part of the culture. You're just going to have more plants. So it's not a matter of just abandoning landscaping. That's not landscaping. That's nothing. So we can do it in an aesthetically pleasing way.
That's really great. Okay, let's see. Oh, I have a 50 to 60-year-old pin oak in my yard. The last few years, it's been slowly failing, and I've been losing large branches. Each year, I wonder what is going on. Would the annual raking of leaves be the only reason that is collapsing this large oak?
No, I suspect it's got oak leaf scorch. It's really hammering the red oak group. And it's going to take out a lot of trees, but there is resistance that's already in the natural population. So we're going to lose a lot of trees, and the resistant ones will remain. I've lost a pin oak, 2 black oaks, and 2 red oaks so far, but I've got a number that are doing fine. So this is what happens when we bring in these diseases, and we just have to muscle through. But I will say, I hear people recommend don't plant oaks anymore. They're going to get sick. I say just the opposite. Plant more oaks than ever so that we can find the ones. We're going to weed out the sick ones and find the ones that are resistant.
Yeah, like we're selecting for the ones that can resist what we have imposed on them. Yeah,
exactly. Right.
Okay, it says here oaks are clearly a winner. What other trees native to Central Texas do you recommend to go with the oaks if you're going to build like a grove or something?
Well, in the hill country, you're in that oak. What is it? Oak juniper.
Yeah, that's our way hill country mix.
Right. And that, of course, is the only place that, what is it, the golden cheek warbler lives? That is the natural habitat. If that's where I live, that's what I would plant. So it depends on where you are. Where I live, the oak hickory forest is what wants to be there. There are other powerful plants too. The native prunus is a very powerful plant. Native willows are very powerful. So if you've got water, you've got a riparian system, that's where you want willows. So you can go to the National Wildlife Federation website and look up Native Plant Finder. Put in your zip code, and the ranked list of the best plants for your county will pop up.
Yeah, National Audubon also has a plants for birds. You put your zip code in, and I think that what people need to realize too is you need different layers, because there's different critters that live at different layers of the landscaping. So we need to provide that. And we have a lot of natives that'll come up, like agarita and elbow bush and these kind of things that'll come up. And people take them out because they don't know what they are, or they scratch you or something, but I don't know what it is. They don't fit their aesthetic eye or whatever. Okay, here's another question. How dependent are oaks on fungi for root development and nutrient take-up? If it's important, is there anything we can do to aid proper fungal development?
Yes and yes. Now we hear a lot about mycorrhizae associations. They are associated with the roots. They help transfer nutrients, and the tree grows really well. I wanted to do an experiment back in the 80s in a greenhouse, and it had something to do with mycorrhizae. I can't remember the question I was asking, but I had pots that had mycorrhizae in it and pots that were not supposed to have it in it. And I was talking to a soil scientist, and he said, well, how are you going to keep the mycorrhizae out of your control pots, out of the ones without mycorrhizae? And I said, well, I'm not going to put it in there. He said, the spores are floating around the air and they will colonize it right away. And I said, well, gee, maybe it's not so hard to get the mycorrhizae as we thought it was. You can help it though. When I planted a lot of my oaks, we had subsoil here. It was just terrible, not much there. So what I did was get leaf litter from under the type of tree that I just planted. If I planted a white oak, I got some leaf litter from an existing white oak and inoculated the soil. Didn't take much, a couple handfuls, and it spreads right away. And who knows if that worked, but my oaks grow really well. So it must have worked, and it was really easy.
That's very, and it's so simple. And there are probably people in your neighborhood that have the tree that would be glad to give you the excess leaves and inoculate them and so forth. And here's a good question too. Will mulching leaves to add to other parts of the yard still provide habitat, or do we need to leave the leaves whole as they fall?
There are a lot of cocoons in those leaves, and when you run them through the mulcher, you're grinding them all up. So it's better than raking the leaves away and throwing them away, but you've also shortened the lifespan. They won't last 3 years when you chop them up like that. So I know we do that because it's you know, it's for aesthetics again, but it's not nearly as good as leaving the whole leaves.
That's what we assume, because there's more surface area when you grind it, and and something we do, we keep our front yard more more neighborhood friendly. Our backyard is all ours, and we can do all that stuff that nobody can see, and you can experiment.
But you can put an oak in a front yard without offending the neighborhood. So
Oh, sure. Yeah.
this is why I don't like the term backyard habitat, because it suggests what we're doing is so ugly, we've got to hide it. And it doesn't have to be. Doesn't have to be.
Yeah, that's true. And ours isn't ugly, by the way. It's just more unkempt than the front.
I know exactly what you mean. Yeah.
Okay, and here's a question: is one oak better than the others? And I know that in the back of your book on oaks, there's a list by area of what where you are. Here's one: Gulf Coast, Alabama. There's a list for Southeast. There's a list for Southwest, and so forth. So go get the book, and you'll have the whole list that you need.
Well, I suspect that you're asking, are they going to support caterpillars and other things better than other species? And the answer is, you know, there's 91 species. We have not compared 91 species, but we have compared 16 species that occur in my area, and they're really very similar. So insects that are adapted to eating one oak, they're adapted to eating high tannin leaves, can eat all the oaks, which means that it's more important to worry about what you just mentioned. Get the right oak for your area, for your soil type, rather than saying, I want the oak that's going to make the most caterpillars, because they all will make a lot of caterpillars. Native oaks. Don't get the Chinese oak. We do not need Quercus sagittarius. We don't need the English oak either. We've got a lot of good native oaks, and they will do much better than those non-natives.
Okay, there's a question here about little plant. Okay, let me back up. I saw your presentation for the Native Plant Society of New Jersey. You suggested that those little plants should be potted first to start the process, protected for a year or two in the pots. Does this still stand, or do you just suggest a direct plant?
No, that's what I do these days because of the rodent pressure. When we moved in, I just planted acorns, but it was so barren here. There was nothing living here, and I got away with it. They all germinated. It was great. If I did that today, they all get eaten over the wintertime with the squirrels and the mice. So that's why I put them in pots. I get them through the winter, or if it's the red oak group, I'll grow them during the summer, get them up and established, and then plant that the first year. I don't keep them 2 years in a pot because they start to get root bound right away. But it's the rodent pressure. And even when they're in pots, you know, if they're in the garage or something, those mice get in. That's your biggest challenge, is getting them through that first winter without the mice eating them. And then, of course, once you put them in the ground, you got to protect them from deer too.
Yeah. Well, we have Saturday here in San Antonio, supported by the San Antonio Parks and Recreation. They're having a little Arbor Day celebration, and we'll be giving away small trees and things like that they've nurtured. And so there's your chance to go. It's over at Mission. Let's see, which park was it? I forgot. Huh?
Lions.
Oh yeah, Southside Lions Club. And I'll get it out. Southside Lions Park. And if you go over there between 9 and noon, we're going to have a booth, and we're going to be talking about plants for birds at our booth, and how important trees are. And boy, we're going to talk oaks a lot now. You got us stoked on that, so we'll be doing that. We talked about oak. Okay, I'm just looking through here. Okay, I think one major problem is that most nurseries push non-natives, perhaps because of greater profits. Any suggestions how to get chain nurseries, Walmart, to get involved with HNP?
And I bet greater profits. It's just that that's what the public has preferred for the last 100 years. So the nursery industry does not believe that you're going to buy native plants. They don't want to stock them and then be stuck with them. We can change that by demonstrating that there's a viable market, and that's happening. Right now, the demand for native plants exceeds the supply, and nurserymen are figuring that out.
Yeah.
They have nothing invested in Chinese plants. They just want to sell a plant. So they want to grow a plant that you're going to buy. And if we demonstrate that we're now planting for conservation as well as aesthetics, they'll come along.
Yes, and that new nursery that we have opening up, Pollinatives, is
Mhm.
going to specialize in that. And if they get more business than the guy down the street, so customers have a lot of power if we just have the knowledge of what we need to do. So I know we're running out of time for your question and answer, but are ash junipers, do they help or hurt oaks? That's the juniper oak woodland that we have.
No, they like each other.
Yeah.
They both do well in the same kind of soil and rocky situations.
Yeah, they evolve together. And yeah, the golden cheek warbler uses both of them for food source, depending on what's producing the most at the time. I think this was going to have to be a last one. A reputable local arborist has notified clients that it's time to hire them to fertilize oak trees. Is such fertilization for established trees warranted?
I am not an arborist, but up here it is certainly not warranted. As a matter of fact, you can kill your tree by fertilizing it too much, and that's because, particularly in the more northern areas, and definitely where there were glaciers, our plants are adapted to poor soils, to low, very poor nutrients. And if we over stimulate them in growth, they will grow so fast that the bark splits. I killed a couple of trees that way when I didn't know what I was doing. Figured, well, a little bit of fertilizer, more will be better. They do very well. And this is very true for prairie plants too. They want poor soil. The butterfly weed, the Asclepias tuberosa, you can kill it right away with fertilizer and water. So give them what they evolved with and they will do best.
That's wonderful. Exactly. Okay, and I don't know, what is a nativar? It says, I wonder about the trend of nativars versus truly native. How dangerous is for our environment?
A nativar is just a cultivar of a native plant. And of course, the horticulture trade's been selling us cultivars forever. It's a genetic variant of the straight species that emphasizes a particular trait. It's usually an aesthetic trait, but sometimes it's disease resistance.
Mm-hmm.
So whether or not it's ecologically equal to the straight species depends on what the trait is. If it's taking a green leaf and making it red or purple, that's loading the leaf with anthocyanins, which is a feeding deterrent, and then you've lost your insect use. Excuse me. But if you make a tall plant short, insects don't seem to care. So it depends on what it is. If you're changing the flower shape, color, or structure, it usually messes up specialist pollinators that depend on that particular flower. But it's not a given. So it depends on what it is. Most of the cultivars are created. There's two reasons. If you patent it, you make a lot of money. Or you're trying to create a trait that's going to make it more usable. So people with small yards, a lot of our natives are tall and leggy. If you make them shorter, you actually can make them more useful. What I don't like about cultivars is that they're clonally propagated. So there's zero genetic variability. And we know that's not a good idea, particularly in the age of climate change. We need as much genetic variability as we can get.
That's a really good point.
This is a good example of how to go to your nurseryman, say, can I get a straight species of XYZ? And he'll say, no, we don't carry that. And say, okay, goodbye. If he hears enough goodbyes, he'll start to carry. He'll realize there is a market here. If you buy something else, there's no pressure on him to ever change.
Good advice. Okay, well, we have somebody, thank you, whoever did this, put a link to the Arbor Day thing that I mentioned, and I'm going to. That's everything in the the,
Chat,
yeah,
chat.
the chat room.